Welcome back, Algebra 2 students. Today we're going to show you how to work in your Pearson program. This is an online assignment program that we'll be doing a lot of. I've used this in the classroom for several years. It works really well. There are a few things you need to know about it, but that's why I'm going to show it to you today. So there will have been a little short video before this one that shows you how to log in and how to get to your assignments. Once you get to your assignment, your first one is 1-1. Your assignment should always say this Math Excel right here. Okay, so we want 1-1 Math Excel. And then we're going to click Start. All right, so some things about this. Right here at the top right is a question help. It has Help Me Solve This. That will take you step by step through this particular problem with feedback and step-by-step instructions, and then it will give you another problem that works by the same steps. It won't be exactly the same problem, but it'll be close. It'll work by the same steps. Then this one says view an example. This one gives you a video. This one is your online textbook. This is a glossary, so if there's a term there you don't know what it means, you can look it up. Math tools. You probably won't need any of these, but if you do, they're there. And what else? And there's a printer. I won't have you printing anything unless you just want to print it for yourself. Okay, so there's question help. Then it'll give you the problem. Right here is going to tell you some of the problems have more than one part. For example, this problem number 1 has 2 parts remaining. I'm going to hide this. Down here at the bottom, you have tells you what question you're on. You can either navigate through next and back, or you can type the number in there if you wanted to skip maybe to number 6 or 7 or something like that. You can type your number in there. This is a review progress tab that if you want to know where you're at, how many questions you've answered, you want to know if you've skipped any, then you can go to review progress. Okay, so what I'm going to do now is work with you through these 10 problems. It's going to take a little while, but I'll be able to show you some things about the program. If you are to the point of working on this assignment, then if you want to open it up, maybe in another tab, the number ones will not be identical. They will work with the same steps and by the same process, but the numbers will be different. Okay, so you can take the steps that I do in each problem and use those same steps to solve yours. So if you are watching this video while you're working your assignment and you come to a problem you already know, fast forward through this part, okay? You may not have to listen to me for the whole thing, but I'm here to help if you need it. Okay, this problem says, every year a Music Hall of Fame inducts legendary musicians and musical acts into its Hall of Fame. The table shows the number of inductees for each year. Complete A through C below. So this is part A. It says represent the data using a mapping diagram. Mapping diagram are these things with the ovals and the arrows, okay? Let 1 represent 2001, 2 represent 2002, and so forth. That's important. Choose the correct mapping diagram below. All right, so it says let 1 represent 2001. So in my table, 1 goes with 11. Your table might be different, but in mine, 1 goes with 11. So I look at choice A, and 1 goes with 11. Choice B, 1 goes with 11. Choice C, 1 goes with 11. That didn't help, did it? I thought maybe we could eliminate. 2 goes with what? 9. So in this case, 2 goes with 9. 2 goes with 4. Oh, it's not that one. And 2 goes with 8. Can't be that one. So I'm going to choose choice A. If that doesn't help you narrow it down with the second one, then you can go to the third one. 3 goes with 10. 4 goes with 9. 5 goes with 8. 6 goes with 4. A is the one that matches. I'm going to come down here and click Final Check. And then this will tell you if it's right or wrong. This is nice work. You're going to get to the point where you love getting these little green checks because that means you're right and you can go on to the next one. If you miss the problem, if you miss that section, be sure and read what's in the box because it will give you a hint as to what you did wrong. Okay, now see this has 2 parts remaining, so I'm going to click Continue. And here shows part A that I got right. Here's part B. Represent the data using ordered pairs. Choose the correct set of ordered pairs below. So what did we have? Look back up at the table. We had 1 and 11, 2 and 9, 3 and 10. 1 and 11? Nope, not that one, not A. 1 and 11 might be that one. It has to be B. That's the only one that starts with 1 and 11. Now, again, your numbers may be different. What does your 2001 go with? Find that here. If you have more than one that's right for the first one, then check the second one. 2, 9, 3, 10, 4, 9. Check them all until you've eliminated. Okay, final check. Boom. Nice work. Okay, one part remaining. Continue. Part C says represent the data using a graph on the coordinate plane. Choose the correct graph below. Now, look at these points. We want 1, 11, 2, 9, 3, 10, and so on. So these graphs are little. Your eyes may be really good. My eyes need it bigger. This is a zoom in or a zoom out, but this is a pop out. There's my graph. I want 1. Notice here's a 2, so 1's got to be right here. And 11. What's my next one? 2 and 9. 2 and 9. 3 and 10. Yes. 4 and 9. Yes. Look at back at my table. 5 and 8. Yes. 6 and 4. So those are all correct. All the points in that graph are correct. So I'm going to size it back down. Click A. Now let's look at B for a second. We know that A is right. We checked all the points, but look at B. 1 goes with 11. And this one, 1 is with 4. Zzz, not that one. This one, 1's supposed to go with 11. 1 with 9. Zzz. Okay, so it was A. We were final check. Nice work. It says that. Sometimes it says different words besides nice work. Okay, now we've done that question. We've done all 3 parts. We got it right. If you missed one section or all 3 sections or 2 sections, if you want, you can do similar question right here, this blue tab at the bottom right. Similar question gives you another problem just like that one, but the numbers will be different. So if you've missed part of it, but now, oh man, I know what I did wrong, then go similar question. That way it will score the correct one and not score the incorrect one. If we got it right, so we're going to go on to next. And this is question number 2. Notice this one only has 1 part. Actually, it says 1 part remaining. Surprise, 2 parts. Every year, Hall of Fame inducts legendary people to the hall. The table shows the number of inductees for each year. What are the domain and range? We know that domain is the input or the X value, and range, which is the output or the Y value. So we have year and the number of inductees, which would be the input, which would be the output. Okay, in this case, the year is the input. Now, this doesn't say anything like the last one about use 1 for this, use 2 for that. So I'm going to type in the years for the domain. I clicked inside the box. Notice this little menu comes up at the bottom. If you need a fraction or an exponent or absolute value, any of these little templates. And if you need more, there's more. That's a little overwhelming, so I'm going to click less. Okay, but there's templates that you need there if you need those for your answer. So what's our domain? The first number is 2000. Now, notice these blue letters right here. These blue letters are instructions, and they are extremely important. Okay, extremely important. If you don't pay attention to the blue letters, it can cause you to miss the question because it tells you how to type your answer in. What do these blue letters say? Use a comma to separate the answers. So after I type 2000, type a comma. Next year is 2001, comma, 2002, 2003, comma, 2004. Okay. Notice it already had the brackets around it. So we just listed the X values, or the input values, or the domain. Okay? Check, answer. Well done. Okay. If you had left out a comma, even though you typed the right numbers, If you didn't follow the directions and type the commas, it would count it wrong and it would give you another chance. So be sure you read the blue letters. Okay, this part of the question says the range. Well, if the years were the range, then if the years were the domain, the range has to be the number of inductees. Blue letters, very important. Use a comma to separate answers as needed. Okay, so our range is 22, comma, 35, comma, 18, comma, 40, comma, 29. Answer? Good job. Okay. Please pay attention to the blue letters and follow the directions so that you will get your answer correct. Okay. Now, you only want to do similar question if you missed one of these. If you got it right, you want to go to next. Determine whether the relation is a function. What do we know about domain and range and functions? We know that in a function, every element of the domain corresponds to exactly one element of the range. So the 2 goes with 14, 4 goes with the -3, 6. Each of these domain elements correspond to exactly one range element. So yes, that is a function. I'm going to show you what happens though if I click no. You answered no. The correct answer is yes. Now, because each element in the domain corresponds with exactly one element in the range. Okay? So it tells you why your answer is incorrect. Okay? I knew that one was a function. I wanted to show you what happens if you get it wrong. So it tells you now, because this one only had 2 choices, they don't give you another chance. But we can go right here. I don't want this to count wrong. So I'm going to go similar question. Is the relation a function? Now notice it looks the same, but the numbers are different. 3 only goes with 1. 15. 4 goes with 1. Now look at this 6. It has an arrow to the -6 and an arrow to the 20. Can this element of the domain go with more than one element of the range? Why, no, it cannot. Okay. Why was the first one a function and this one not? The first one, each element of the domain, each x, each input only went with one output. In this case, the 6 goes with more than one element of the range, so it is not a function. Okay, notice down here, question is complete. Similar question. No, we don't want similar question. We already did similar question. We'll go next. Determine whether the relation is a function. How will we know from these ordered pairs? If each x goes with only one y, then we have a function. So let's look. There's a 5. Goes with -6. 4 goes with -6. 3 goes with -2. Okay, did the x's repeat? No, they did not. The x's didn't repeat. This 5 only went with one number, -6. This 4 only went with one number, -6. This 3 only went with one number. So yes, this is a function. It does not matter that the y's repeated. It only matters if the x's repeat. Final check. Fantastic. Next question. Use the vertical line test to determine if the graph is a function. The vertical line test says that when you have a graph, you can draw a vertical line, and if it crosses more than once in any spot, then that graph is not a function. So we're looking at the red part here. If I draw a vertical line anywhere here, it's going to cross that red part twice. So this is not a function. If it's a function, any vertical line will only cross once. Again, you can make that graph bigger if you need to. Final check. Nice work. Okay, next. Given f of x equals 22x plus 12, find f of 5. Notice this says f of x, this says f of 5. So they changed the x to a 5. So change this x to a 5. In other words, this is called function notation. It just means plug this number in for x. So I need 22 times 5 plus 12. You can use a calculator on your phone. You can say, if my phone's in my pocket, you could ask Siri. You could use your calculator. I'm going to go to Desmos. Just open a new tab. Desmos.com. Now, Desmos has a scientific calculator. They have a graphing calculator. We don't need the graph, but we can still type our problem right here and it'll give us an answer. So what I need, 22, replace the x with 15 plus 12. So 22 times 15 plus, oops, I didn't want to go to another line, plus 12. See my answer right here, 342. Go back to my Pearson. What did I say? Don't get old, it's no fun. 342. 342. Okay, so what did I do? I took the 5, I plugged it in for the x. I used my calculator. You can use your phone calculator. You can use Desmos. You can use Siri, however you want. What I need to know is that you know to plug the 5 in for the x. Check answer. That's incorrect. What did I do? Substitute 22 times 5 plus 12. Look what I did. I typed it in wrong. 22 times 5 plus 12. 122. Thank goodness Pearson gives us another chance. 122. Very common mistake. Type something into the calculator incorrectly. That's better. Now, when it scores this, it will count that problem right. Okay. If you miss it again and it gets final answer and you miss it again, you might go through question help or figure out what you did wrong and then do similar question. Okay. Next. State the domain and range of the following function using set notation. This is set notation. We're going to talk a little bit. We'll talk more about that as we go through the year. Set notation, inequality notation. There's one more, interval notation. But this says set notation, but you have multiple choices. So I need to know domain and range of 7x squared. Domain is the x values, range is the y values. So I'm going to go back to Desmos in my other tab. I can take out this one. And what was that? 7x squared. Yours is probably different. I've seen in this one, somebody may have 10x squared. Somebody may have x squared. Just type whatever you have. 7x. You can use the up arrow above the number 6. And there's my graph. This question asked me for the domain. Domain is the x value. So I need to know how far to the left and how far to the right, because those are my x values right along the x-axis. Does this stop anywhere to the left? It does not. It keeps going. Does it stop anywhere to the right? It does not. It keeps going. So it's not greater than any number or less than any number. It's any real number because it continues to the left to a negative infinity, continues to the right to positive infinity, and beyond. That means it's a real number. This reads x, all x values such that x is a real number. That's set notation. The second part of this question asks, what's the range? Let's look back at the graph. Range is the y values. Y values, the y-axis goes up and down. So I want the lowest y value. Here's a Desmos thing. If you hover or click on this point, it tells you what it is. So my lowest y value is 0. What's my highest y value? Do you know with Desmos you can zoom just using your fingers, like one finger or two fingers? Look, it just keeps going. It doesn't stop to the top, right? So the lowest y value is 0 and the highest y value is infinity. So let's look back. It's not all real numbers, right? Because we don't have any negative y's. This says less than. But all our y's are greater than or equal to 0. So I'm going to choose choice A, and I'm going to fill in this blank with a 0. Check answer. Fantastic. Next question. You only want similar if you missed one, okay? List the domain and range of the relation. There's those blue letters again. Use a comma to separate the answers. Domain goes with x. So you have 1, comma. Okay, this one has, we got 1, 2, Oh, I hit enter. You shouldn't hit enter because that's the same as check answer. Okay, notice this domain. We have 1, 2, 0. There's another 2 and there's another 1. That tells us something. It tells us it's not a function because the X repeats. Also, when you type those in, don't type them twice, only type them once. So what do you have? 1, 2, and 0. Notice when you get to this ordered pair, we have 2, but we already have 2. This one is 1, but we already have 1. Okay. And we used our comma to separate our answers. Check answer. Well done. The range is the y values. Again, if it's listed twice, don't type it twice. Only list it once. Only type it once. So we have -8, 2. Do we need this -8? No. We have -8, 2, 1, and 8. -8, 2. We don't want another -8. A 1 and an 8. And we have commas between them. Check answer. Okay. Domain is the x values, range is the y values. If they repeat, do not list them more than once. It will count it wrong. And follow the blue letters, separate with a comma. Okay. Next, you can see down here that we're on number 9 of 10. Find the domain and range of the relation to determine whether it is a function. Okay, notice these answer choices are written in interval notation. What this means, if you've got the x in the middle, it means all the x's are between -6 and +6. Or all the x's are between 0 and infinity. Or choice C, all the x's are between -3 and +3. Or choice D, all the x's are between -infinity and +infinity. So let's look at our graph. Again, we can pop it out, make it bigger. What do these arrows on the end mean? These arrows mean the graph keeps going. So do we have a stopping point to the left? We do not because of the arrow. Do we have a stopping point to the right? We do not because of the arrow. That means our x's go from -infinity to +infinity here. It doesn't stop at -6. It doesn't stop at 0. It doesn't stop at -3 or 6 or positive. It doesn't stop. It goes from -infinity to +infinity. Okay. Got 2 parts remaining. Continue. What is the range? The range describes the y values. So let's pop this graph out again. What's the lowest y value? 0. There are no y values down here, right? The lowest y is 0. Is there a stopping point as we go up? It goes from 0. Does it stop going up? It does not. So the y's are all between 0 and infinity. Let's look at your answer choices. Not between the 6's, not between the 3's. 0, all the y's are between 0 and infinity? Yes. Why is it not this one? Between -infinity and +infinity, that means all real numbers. But this one stops at 0. There are no y's below. That's why it's not that one. Okay. All right, one more. Miss Riddell, get off your phone. Okay. Is this a function? Look at your graph. We can use the vertical line test. If we can draw a vertical line anywhere in the graph, it only crosses once, it is a function. If we draw a vertical line anywhere that crosses twice or more, it's not a function. Vertical line, vertical line, vertical line, vertical line, a vertical line only crosses once. So yes, this is a function. Any vertical line would only cross once. Okay. One more question. The volume of a sphere is a function of its radius. Here's the formula, 4/3 pi r to the third power. Evaluate the function for the volume of a volleyball with a radius of 10.1. When you have the radius, we need the volume. What are we going to do with that radius? We're going to plug it in for the r. Okay, so we have 4/3 pi r to the third. So I'm going to go to Desmos. take out the one we typed before. I don't want to worry about this graph because all it wants to answer. All right. 4/3. Now we need pi. Don't use 3.14. Use the pi symbol. Go down right here to the bottom left. There's a keypad. And right here's a pi. Now I want to be out of the fraction. So use my arrow key. 4/3 pi r, which our radius was 10.1. Close parentheses. Raised to the third power. You can use the up arrow that's by the 6. 4/3 pi r to the third. Now, here's my answer. 4,315.714. Your numbers will be different if your radius is different. The Pearson problem asks you to round to the nearest tenth, I believe. Yes, blue letters, round to the nearest tenth. Tenth is 1 decimal place, so this decimal place is a 7. How do I know whether to keep it a 7 or make it an 8? You look at the number next to it, which is a 1. 4 or below, you leave it the same. 5 or higher, you raise it. So since that's a 1, that means the 7 is going to stay the same. 4315.7. 4315.7. It already has centimeters to the third. Check answer. Fantastic. Okay, that's number 10. So we're done. If you try to go next, okay, it just takes you to review progress. You can either hit next or you can go to the review progress tab, and it tells you all of your questions, 1 through 10, and whether you answered them or not. And you can go back and view that question if you want, if you skipped any, if you want to go back and look at any of them again. When you are finished, you hit submit my work, and it will show you a score. Now, if you're not happy with your score, you can try again. When you hit try again, it's going to take you back through all 10 of those questions. So the better plan is, if you miss one, is to go to similar question while you're working in before you hit submit. All right, that is your Pearson problem. We'll be doing a lot of those assignments. I took you all the way through that one so that you could see how the program works. And that is it. Now I got to see how to make this quit.